Hello, welcome once again to the Maths Jedi channel. If this is your first time here, here's another of my lessons in the A-level series. This one's going to be on graph transformations. If you're new to the channel, please do leave a like and subscribe. That would be really helpful and help the channel out a ton. You might also take an interest in some of the other A-level videos that I've done. That would very much help me out if you could just tell your friends and let them know that I'm here helping you at this time, obviously to make sure we're going through some A-level content, making sure we get it done before the end of the year as we normally would. This particular PowerPoint today takes you through graph transformations and also mentions transformations that you wouldn't have done at GCSE. So we're going to be doing transformations on graphs that you didn't do at GCSE, used to be covered by the GCSE syllabus but aren't anymore, and we'll look at those in particular, and there'll be an opportunity for you to try and practice questions at the end. Let's first of all review what the work was that you did at GCSE and make sure we understand common transformations of graphs and how they work. So there are 4 transformations that you learned about graphs when you did it at GCSE, these 4. So f of x plus a, f of x plus a, minus f of x, and f of minus x. Those are transformations that you learned at GCSE. Hopefully you recognise the functions notation. That's something you'd have done at high tier if you'd done it all the way through, making sure you're aware of how these things move and affect graphs. So let's look at graph transformation number 1 first of all. So looking at f of x plus a. So we're going to start off by looking at this transformation by looking at a familiar graph, a graph we should be familiar with, a quadratic graph. So here is a basic quadratic graph, graph of x squared, and we're going to look at the graph of x squared plus 2. So here's the graph of x squared plus 2, f of x plus 2. So that's the graph of f of x plus 2, x squared plus 2. So what's happened to my graph? Well, obviously you can see, hopefully, it's moved everything up by 2. And if I look at f of x minus 2, what does that do to the graph? Let's look at that. Here's f of x minus 2. So what's that done to my graph? It's moved everything down by 2 to minus 2. So this is x squared plus 2. This is x squared minus 2. So this graph transformation transforms in the vertical axis. It makes a vertical shift, and the vertical shift will be whatever your constant is at the end. So plus a obviously moves it up, minus a moves it down. So it shifts the graph vertically. So f of x plus a shifts the graph vertically. Let's look at the second transformation. This is f of brackets x plus a. So this time the a is in the brackets. So again, let's look at a familiar friend by understanding it. This is x squared again. But now I'm going to look at x minus 2 all squared. So x minus 2 all squared. So the graph of x minus 2 all squared is this. And what's happened here is that the graph has shifted to the right. It's moved 2 places to the right. Common misconception, people always think that because it's a minus 2, it must move it to the left, but it doesn't. It's the opposite of what you expect. So the minus 2 shifts it to the right. That must mean then that the positive 2, here's f of x plus 2, shifts to the left, and it does. So this is the graph of x plus 2 all squared, x plus 2 all squared, and x minus 2 all squared. This graph minus 2, this graph has a minimum point at minus 2. This graph has a minimum point at 2. So what does this shift do? This shift moves it right or left. It's a horizontal shift, and it will move it in the opposite way to the sign of the a in the brackets. So if it's minus 2, 2 places to the right. If it's minus 2, if it's plus 2, sorry, it moves it 2 places to the left. So minus 2, 2 places to the right, and then positive 2, 2 places to the left. So it shifts the graph horizontally. You should have learnt this at GCSE, but just to recap. 2 more transformations to do. This one here, y equals minus f of x. Again, if we start off with a very simple problem, we're going to see how this works. So I'm going to look at that with a particular example. I'm going to use Desmos for this. So here's Desmos just sitting behind here, and here is my formula I'm going to use. So this is a fairly simple graph that I'm going to use, a cubic graph, just to illustrate this fact. What transformation we're looking at is minus f of x. So I'm going to think about minus f of x. So here's my basic function. And now I'm going to think, well, what's minus that? are going to look like. So I'm going to put in the equation of the graph, minus x cubed minus 3x plus 1, close the bracket and press equals, and you can see what's happened. So what has putting a minus in front of all of this done? It's reflected it in the x-axis. So minus f of x, so that's what it does. So minus f of x is a reflection in the x-axis. That's what minus f of x does. It's a reflection in the x-axis. What about f of minus x? What does that do? Well, I'm going to use the same function again. So here's the same function I'm going to do. So here's Desmos again. Let's take that one away. So now I'm going to imagine where I see an x, I'm going to put a minus x. So I'm going to put minus x all cubed minus 3 lots of minus x and then plus 1. So all I've done here is I've put a plus 1 here. So you can see all the way through I've put a version of the problem in. So you can see all I've done is put a minus x where I put an x before. And what's that doing? You can see the green line, what it's doing. It's reflecting the graph in the y-axis. So f of minus x is a reflection in the y-axis. So f of minus x, a reflection in the y-axis. Now it's important you get that really well learned and understood. Again, that's something you should have done at GCSE, but just to remind you. Now, what about those transformations that you didn't do at GCSE and are important for A-level? Well, there are 2 of them, and they're these 2. So they are called stretch transformations, numbers in front of functions of x, or numbers inside of the brackets in front of the x. So AF of x and the function of AX. Again, we'll look at what these do by looking at what they do to familiar curves. So this is the graph of AF of x first of all. So we'll start off with a quadratic expression, x squared. So here's x squared. And I'm going to look at 2x squared. So what does that do? So putting a 2 in front of my x squared, this is 2x squared. So you can see it's got steeper. It's important to look at values to understand what it's doing. So in the original graph, 2 would give you 4. So 2 squared is 4. But in this new graph, 2 gives you 8. It's double as much. So you can see that the y output for the original graph has been doubled. It's doubled the y output. So it's stretched the graph. It's stretched the graph vertically by a factor of a, in this case 2. Stretched it vertically by a factor of 2. The other way of thinking about it is that it multiplies the y coordinates by a. That's something I used to tell GCSE candidates because it was useful for them to know it. But just be aware, I think this is more A-level speak. Stretches the graph vertically by a factor of 2 in this case. What about the other one? F of AX. So f of AX, first of all, we've got to look at that and understand what that does. So f of AX, let's look at our familiar graph, x squared. Here's x squared. And we're going to look at 2x all squared. So 2x all squared, very steep. What's that doing? Let's again look at values. So 2 would have produced you 4 in the original graph. But to get 4 in the new graph, you only need 1. 1 gives you the same output. So 1 in the new graph gives you the same output as 2 did before. So in other words, it stretched the graph, but this time it's a horizontal stretch, and it's a horizontal stretch by a factor that's 1 over the number you expect. In other words, it's halved it in the x coordinates here because the number was 2, so it's halved the x coordinates here. Again, you can think about that as dividing the x coordinates by a way to think about it. So 1 is a vertical stretch, 1 is a horizontal stretch. 1's a vertical stretch by a product, by a component. In the previous case it was 2, and this one's a horizontal stretch, but it's a component that's factor 1 over a. It's 1 over whatever it is that's inside of our brackets. Let's just have a look at a couple of examples to get a head around that. So this is from the book, page 80, if you want to look it up, exercise 4G. It says the following diagram shows a sketch of the curve with the equation y equals f of x. The points A, B, C and D lie on the curve. And it says sketch the following graphs and give the coordinates of the points A, B, C and D after each transformation. So I'm going to get my notepad up here so we can have a look at that. Let's try and make it a bit there. So we're going to have a look at this together and see if we can figure this out. So let's have a look first of all after the transformation x plus 1. So what's that going to do? Well, it's plus 1 here, so that's going to move everything one place to the left. Everything's going to shift one place that way. So everything's shifting one place to the left. It's a horizontal shift, one place to the left. So A, whereas at 0, 2 before, is going to be at minus 1, 2 when it moves. This is at 1, 0. This is going to be at 0, 0. 4, 4. This is going to be at 3, 4. And then 6, 0. That's going to be at 5, 0 when it moves. B, f of x minus 4. That's going to move everything down by 4. So that's one place to the left. This is 4 places down. And so again, things like C, 4, 4 before, 4, 0 it will be, and everything moved down 4. Let's get to the stretches. So D, f of 2x, that's stretching everything up by a factor of a half. It's stretching everything horizontally by a factor of a half. So that's that last one we looked at. That's going to halve all of my x coordinates. So rather than B being here at 1, 0, it's going to be a half, 0. Rather than D being 6, 0, it's going to be 3, 0. Rather than C being 4, 4, it's going to be 2, 4, and so on. A stays where it is. This one, 3f of x, that's going to stretch it vertically by a component of 3. So that's stretching everything out by a component of 3. So whereas A is 0, 2, it's going to be 0, 6 in my new graph. 4, 4, it's going to be 4, 12 in my new graph. But B and D will stay where they are. And so on. I'll leave you to do the others in this exercise, but this is all good thinking, worthwhile trying to make sure you understand how these graphs look. Do get hold of these stretches because that's the ones that you haven't done before. Do make sure you take an opportunity to look at these and make your way through them because these are all good questions to have a go at and practice. I hope you will do those at home, and thank you for watching. Hope to see you again soon. Thanks. Bye bye.